So we have question. We have the theta is it can range from negative pi to 2 pi, and we have a complex number 1 plus I cosine theta divided by 1 minus 2 I cosine theta, and we're told that it's purely imaginary. So what's the sum of all possible theta within this interval that makes this condition true? So first thing first, I see a complex number like this. I see a complex division. I think what I'm going to do is I'm going to multiply top and bottom of fraction by the conjugate of the denominator. So I'll get 1 plus I cosine theta over 1 minus 2I cosine theta times 1 plus 2I cosine theta over 1 plus 2I cosine theta. And then that'll get me 1, so first outer, so 1 2I cosine theta plus I cosine theta, 1 plus 3I cosine theta, and then multiply last terms, so you get 2I squared cosine squared theta, so minus 2, right, minus 2 cosine squared theta. Okay, so I have that, and the denominator as difference of squares basically, but we have an I, so we end up with 1 plus 4 cosine squared theta, right, because minus 2I squared, that's same thing as plus 2 squared plus 4, right? So we have that. And what I'm going to do is I'm going to break this fraction apart into real and imaginary parts. So I'll rewrite fraction like this. I'll get 1 minus 2 cosine squared theta over 1 plus 4 cosine squared theta, and then plus I'll do this, plus I times 3 cosine theta over 1 plus 4 cosine squared theta, right? You should be able to see this, yes. So basically I have this, right? I just broke it apart into real and imaginary parts, and now we're told that this fraction which turned into this is purely imaginary. So it's equal to some complex number, but it was equal to some complex number x plus iy, but x is equal to 0 because it's purely imaginary. So it's really equal to 0 plus some iy. I didn't need to say all that, I could have just written that, but whatever, right? So there we have another condition. The real part needs to be equal to 0. So all this, 1 minus 2 cosine squared theta over 1 plus 4 cosine squared theta, that has to be equal to 0. So you get an equation right here. 1 minus 2 cosine squared theta is equal to 0, right? Multiply, because if we have this equation 1 minus 2 cosine squared theta over 1 plus 4 cosine squared theta, multiply both sides, right, by 1 plus 4 cosine squared theta, we get this equation, right? So then we can rearrange stuff, and we can get that cosine theta has to be equal to plus or minus root 2 over 2. I just did algebra. And then we can get the theta, right, from the range we have here, from minus pi to 2 pi. Theta could be equal to, let's see, I'll start with from 0 to 2 pi. So let's see here, we think about unit circle, we see, okay, theta can be equal to pi over 4, alright, 3 pi over 4, right, 5 pi over 4, right, and 7 pi over 4. Well, that's from 0 to 2 pi. From 0 to negative pi, let's think. We can have negative pi over 4, right? Negative pi over 4. And we can have negative 3 pi over 4, right? So these are all our possible values of theta in this interval. So we need to find the sum of all theta. So just add this all up. So let's see here. We have all the same denominator, just add stuff up basically. So let's see here. Pi plus 3 are 4 pi, 4 pi, 5 pi, 9 pi, 9 pi, 7 pi, 16 pi. We have 15 pi now, subtract 1. So 15 pi minus 3 pi, 12 pi. So we have 12 pi over 4, which is 3 pi. So that's the sum of all theta, right? That satisfies all the stuff. So really, not that bad of a problem. It's kind of fun, complex number problem. And follow for more stuff like this.